So far in the bridging videos we've been looking at right angle trig. Now what we're going to look at is when we have scaling triangles, non-right angle triangles, and we're going to look at two rules for finding missing lengths and angles. The first one we're going to introduce is the sine rule, and this is extensively covered, which I'll link up to this video throughout my channel. What it says is essentially if we have A, which is an angle, and its opposite side A, and then we have another angle, B, and its opposite side, then we can build up a ratio between these. Now, we will look over this and the cosine rule. So this one is called the sine rule. And this will find us missing lengths and angles in non-right angle triangles. We use this when we want to find a missing length or angle when we've got a non-enclosed angle. If I had this side here, which would be C, then B and C enclose or A is enclosed between the angles B and C. This is when we don't have that. And the sine rule says that A over sine A is equal to B over sine B. It's equal to C over sine C. But if you're using C over sine C as well, something's gone a little astray. We only ever need to use these two ratios. You might need to relabel things up, but essentially if you can show, don't have to be A's and B's, can be P's and Q's, X and Y's, whatever. But we need to form this relationship, and that will find us a missing length. It will also find us a missing angle, but to find a missing angle it's often very straightforward and easy to write sine A over A is equal to sine B over B, and that's my preferred choice to find an angle because you've got less work to do. So let's look at this in practice and see how we can apply this. So here we go. We're going to find this length right here, and I'm going to call this one little w. So what we've got here is little w, and this is little v. So we can say now we're trying to find that little w. So w over sine of big W is going to be equal to v over sine of big V, although that's a very big V, isn't it? Let's make that just a touch smaller. There we go, little v. So let's fill in the information. It's going to be w, which we don't know, over sine 45. The sine of 45 degrees is 1 over root 2, which you'll learn later in your studies. And then we can write that is equal to 12 over sine 75. So all we need to do to find w is multiply both sides by sine 45. So w is equal to 12 sine 45 all over sine 75. And that will give us that direct length from there. So let's grab a calculator and do that one. Okay, right. So what we need, check you're in degrees mode. Shift mode 3 is degrees on this one. And you've got 12, and we can just write it in as 12 sine 45 over sine of 75. And this will give us the answer. Okay, and then we've got 8.78. So 8.78, and that's going to be in centimetres. So let's look at the next one. We want this one right here. We'll do this one. So I'll call this big A. So what we've got now, this is little c and big C. So all I need to set up to find, in fact that should be a lowercase a over sine A is going to be equal to C, which is going to be little c, over sine of big C. You don't need the little and big, it just makes some form of sense. So let's fill this in. A, at which we don't know, sine of 37 degrees is equal to 8 over sine of 72 degrees. So A is going to equal 8 sine 37 just by multiplying both sides over sine of 72. So straight into the calculator we go with that. So 8 sine 37 over sine 72. Once we've looked at the cosine rule, we'll combine the two and look at some problems involving them both. 5.06 centimetres. So that's finding a missing length. Now, what we'll do here is find a missing angle. And what we can do with this one, as I said, often it's easier to write it as sine A over A is equal to sine B over B. Because then that gives us the option to do the following. We can write sine A is equal to A sine B over B, And then of course A is just going to be sine to the minus 1 because we're undoing this. We're doing the inverse, A sine B over B. So let's take you through those steps. Sine A over A, this is the angle we want. We want A, we want the angle A. Sine A over A is equal to sine B over B. Multiply both sides by the A, which gives us sine A is A multiplied by sine B over B. And then A, we just inverse sine both sides. So let's find this angle here. And we'll do that one. So what we've got now is the following angles. We want sine Q. So sine Q over Q is going to be equal to sine R over R. So let's fill in that information. Sine Q we don't yet know. So there's sine Q over Q. Well, Q is 13. And that's equal to sine R. R is 64. So sine 64 over 12. So what we're going to get, sine Q is going to be equal to 13 lots of sine of 64 over 12. And then all we need to do, Q is going to be equal sine to the minus 1 of 13 sine 64 over 12. So straight through the calculator as follows. Shift sine, so sine to the minus 1 of 13 sine 64 over 12. The proof of this is also on my YouTube channel if you want to check it. So that angle, we'll call that 76.8 degrees. I appreciate the last one's wanted this to 1 decimal place. I've been doing them to 2. But we're not really focusing on that. Okay, let's do another one then. Let's find this one. We want, what should we go for? We'll go for this one right here. Now, it may be that you're asked to find the other one, which means a lot of the time you're just going to have to double up. You find one and then subsequently find the other. Or if it's a case of just finding the side length, you can just subtract away the angles and work from there. So what we want is sine E over 10 is going to be equal to sine 20 over, sine 78 over 20. I've put the length in there, haven't I? Sine 78 over 20. So multiplying both sides. Now you'll see what's going to happen here. Sine E, all we've got to do now is write sine 78 over 2. The 10 and the 20 will just drop out. So E is going to equal sine to the minus 1 of sine 78 over 2. And be careful with your trig. Don't just go saying, well, I'll just take half of the angle. You've got to ensure that you're taking half, the sine of half of that angle inside the brackets there. So let's now do that. So we want shift sine. Again, we've checked we're in degrees mode last time. Sine of 78 over 2. And don't be tempted to say it's sine of 39. Don't try and cancel those. Completely different animal. 29.279. So we'll call, what are we doing, 1 decimal place, aren't we? 29.3. 29.3 degrees. So there we go. Take home message. It's when we have a non-enclosed angle and we need to find either missing length or angle in a non-right angle triangle. The general idea is sine rule. A over sine A is equal to B over sine B for a length. Sine A over A is equal to sine B over B for an angle. You can of course use this. If you wanted to use that one, what you can do, you can rearrange your formula. You can multiply up here. So you could say that A is equal to B sine A over sine B. Multiply it by the sine B and divide by the B. So you'd end up having A sine B is equal to B sine A. And then divide both sides now by the B. So it'd be A sine B over A sine B over B is equal to sine A. I prefer just doing it from the start and turn it over. In fact, so much so that I'm liable to actually do this bit wrong. So I prefer that bit just there and work from there. In the next video we'll look at the cosine rule when we apply the cosine rather than the sine rule, and then in the one after that we'll look at applying them both together and finding some missing lengths and angles in some more tricky problems. But this is an absolute must. The sine rule you'll use extensively.